But anyway, since I mentioned it, leaving on a jet plane, my bike is right inside here, so I can leave immediately following class and get things packed up, because the flight leaves at 2:10, so I want to get to the airport at like 10:10, which is kind of unrealistic because we end at 10:10. But the earlier the better, I figure. So anyway, to remind you, the plane doesn't come back until late Sunday night, and so Monday morning is optional. I'll be wandering around, probably in like a stupor, but I'll be here. I have at least one of my Calc 1 students who says, I need help, and I said, come on in. I'll do my best to help you. So if you need help, you can wander in. If you wander in too late though, if it's like 9:45 and I'm not here, then wander over to my office, because I might decide no one's coming and I want to be outside or I want to go somewhere else. So yeah, do come if you want to Monday. So Monday, optional. Tuesday though is non-optional. Be here Tuesday. So I won't be recording anything on Monday, just so you know. It's just whatever you need help, come. If you want me to do your homework for you, come. I'll do it for you, seriously. This isn't homework. Hold on. Let me switch over. This is, whoever, if you're watching the video, you're like, what is that? Hold on a sec. Let me close this down. That's not either. That's Calc 1. Let me pull up Calc 2. And I will also remind you, oh, wait, what's this? Power series? What? Yeah, that's not right. I'll deal with that later. Let me just view this. The one that matters, I mentioned last time. Hopefully you didn't get confused about that now that I see this. It's this one, the 11.6 absolute convergence and the ratio and root tests. And so let me just go down and see where we are. Where are we? Ratio test. I just want to get to the point where it switches to root test. Ratio test, root. Okay, so there it is. So everything up through here you should have been able to do for today. I had encouraged you to do it even though it wasn't due till Monday. However, I realized that you might not be as committed to getting it done early. So you might not have done this. However, just want to see if there are any questions up through number 9. Anything up to 9 if you've done it. If you haven't done it, what do you think? I can do number 6. See, it's not due till Monday, but I'll do it anyway. So let's go find number 6. Up here, is that 5? There's 6. Let me zoom in. I can't see a thing. Ah, that's better. So it says use the ratio test to determine whether this series is convergent or divergent. And then it says evaluate this limit. So, I see. So it's basically walking you through this. So the first thing to do is to identify A sub n. That is A sub n. So here, I might as well type this up. Hold on a sec. Let's see. Is that there? Yeah. A sub n. So you just type this, -3 to the n divided by n squared. So there's A sub n. The next thing, what is the limit? Well, here we actually have to do some work. Whoops. So we will go find some place to do our work. And I'm just going to copy this, and then we will do it. Oh, not that. Okay, so this is A sub n. And what we're doing is we're going to do the limit as n approaches infinity of A sub n plus 1 over A sub n. Just to remind you, what this does for you is it kind of uses the geometric series as a proxy, and it says, if you have a common ratio that is similar to the ratio, or similar to the geometric series, if the common ratio is very close to a number that is between -1 and 1, then you're going to converge. So that's basically what this is doing for us, is it's saying, let's just pretend that this is geometric, and if it's geometric, it will converge if the common ratio is between -1 and 1. So let's do this limit, negative 3 to the n plus 1 all over n plus 1 squared all over negative 3 to the n over n squared. And we're doing the limit as n approaches infinity of this terrible notation there. Sorry about that. Let me see if I can at least clean this up a bit. That's a little better. Let me get rid of that and put a new line in. There. Now that looks a little better. So we're dealing with this. Now we just have to do the math. First things first, the absolute value means that the negatives don't matter. So let's drop the negatives altogether. Also flip the denominator and multiply. So this will be 3 to the n plus 1 over n plus 1 squared times n squared over 3 to the n. Does that look okay so far? Looking good. Now I just have to do some algebra. So this is going to equal the limit as n approaches infinity of, when you divide exponentials, you subtract the exponents. So this will be 3 to the n plus 1 minus n times n squared all over n squared plus 2n plus 1. So all I did there is I just multiplied that out and I combined those as a single exponential. And now I'll clean this up. Let me pause there because there's where all the algebra sort of fell into place, hopefully. And see if you have any issues with my algebra. Now we'll do some calculus, but algebra first. Everyone's happy with the algebra? Look at this, I'm doing one of your problems for you. Now the final thing is this, the calculus, which is that this limit is 3. Do whatever you need to get this. L'Hopital's rule, use the little trick that you know. That's what I did. I was like, oh, n squared, take the leading coefficients, I get 3. Okay, so the thing is that 3 is bigger than 1, and so this will diverge. Remember that we're kind of using this as if it were a geometric series, and this limit is kind of like the common ratio. That's the whole thing with this ratio test. And so because we can do this, we get to use the same idea. When it's bigger than 1, you're going to diverge. Less than 1, converge. The only thing that the edge case is the only one that we don't know about is that when it equals 1, go either way. We don't know. So, Tony, you happy with that one? Oh, we're not done with it, I guess. But, well, we're practically done with it. We talked through it. There it is. So, answer here is, oh, do we put a D and E or an infinity? What do we say there? Let me see. Does it give us an option? D and E? Oh, no, it's 3. It's 3. Never mind, sorry. I was thinking of this one. Okay, so since this limit is greater than 1, then you diverge. That's better. Okay, so that should work. Let's go check, though. So I know you're dying to know if I know what I'm doing. Here we are. What was that, number 6?
Yeah.
So many. Why are there so many? Yeah, I got it right. Phew. Well, there's one down, so you don't have quite as many homeworks if you paid attention. If you didn't pay attention, you can always go and relive the magic through the video. Okay, is there anything else from this that we need to at least touch on before Monday? This is due Monday. I know we don't have class Monday. Well, we have class, sort of. I'll be here for you, but it's optional. However, the homework is still due Monday, so make sure you do it for Monday. So anything else? We're happy? What do you think?
Is that question like the one on the first?
What was that?
Is that question like the one on the first?
Let me look. Yeah, there's a quiz question that looks like that. Excellent. Yeah?
With this one, is the limit, so if I thought about it right, it'll always be the red number in your answer?
Yes, in this case.
I'm not going to do that.
No, this is correct. That if, yeah, so one way to No, you're thinking like a mathematician. So there's two ways to do what Pearson's doing. One of them is to do practice another version, which is you look for where the red number ends up, and you don't care about the math. Pearson, though, cares about the math, and the way you do this as a mathematician is you say, what if that red number was the letter A, capital A, let's call it, capital A, then here this would be capital A, and then this would be capital A. That is mathematics. So thank you for that. And then so whatever capital A is, if that was 1/2, then you would converge. If that capital A is bigger than 1, like 7, you would diverge. Yeah, that's beautiful. Yeah, I'm not a fan of practice another version because of that. Because after a few times of using this, even my daughter, who took this class at one point, she's like, yeah, all you got to do is you go to practice another version. And she explained to me, I was like, no, don't do it that way. So this is the middle child, not the youngest. The youngest was much more careful with her math. So, anything else? We're okay? We're happy? You want to try it? Quiz? Yeah, let's do a quiz. Give it a go here. We can do this. There's 2. Oh, here. You want one, Briar? And if Tony wants one, you can give one to him. Oh, sorry. There's several. You can share with your friends. Here you are. Here you go. One more. You want one? Sure, you have so many extras. Does anyone want an extra one? All these. Good job. Put it up on the screen. So by the way, Sydney's question, it was number 2 is very similar to what we just did. So not identical, but if you're looking for the one, it's like number 2. I just realized number 2. Here, I'll help you out. Just a sec. This. Sorry about that. There. If you want to know what n plus 1 to the 5th is. Sorry about that. I don't know what I was thinking. I was like, oh, n to the 5th. That's easy. Yeah, not n plus 1 to the 5th. Some of you look like you're done. Let's take a peek, see if I got it right. No, I'm not gonna rush you. I'm gonna rush you. I always ask if I'm not gonna rush you, you're like, yeah, you're rushing me. You never tell me that, you gotta let me know. What do you think? Got something? I don't see anything wrong. Wait a minute. You didn't write whether merge or diverge. Something happened. All right, excellent. Okay. All set? I'm not gonna rush you yet. We'll come back around one more time. Okay. Any other rushers? All right, excellent. So, yeah, I'm learning, so this is good for me, that I need to make sure that on the actual test, this doesn't happen, right? It's got to be simple, right? So I apologize for that, but it's okay. It's getting it out of my system, and it's kind of like, well, that's a little bit harder than we had on the quiz or the homework. Let's see how we did. Here, I'll go back to the beginning here, and this first one, I started off like this. So I think all of you started off like this. You can write this. I mean, this is half the battle. If you've done this, then you got at least half credit, all right? So you wrote something like this, and then you're like, what do I do with the factorials? I forget. Okay, well, we'll get to that. So now we're going to rewrite this like this. And all I did there was I took the denominator and flipped it, so this, and I kind of rearranged, but that's all that is. So still, algebra, you can do this part. The next step, here's where things get a little dicey with the factorials, is you have to remember that n plus 1 factorial is the same as n factorial times an additional n plus 1 term. You could write it all out and cancel if you want, but I was just like, you know, it's like 10 factorial is the same as 9 factorial times 10, 7 factorial is the same as 6 factorial times 7, so I just canceled everything except for the n plus 1. And then here, when you divide this, you get 10 n plus 1 minus n down here, or vice versa. But anyway, you get this. And that equals infinity, which is definitely bigger than 1. Some of you had actual numbers there. I don't know where that came from, but yeah, this limit for sure goes to infinity. Maybe it's because you did your algebra different than mine. So because that goes to infinity and bigger than 1, that diverges for sure. Okay, first one's down. So I think most of you had diverge, converge. Some of you had converge, diverge. I don't know why. I'll be looking at it. Okay, so the second one, as you might guess, that one converges. So let's see why. So you should have hopefully been able to write this down, although mine's messy. Let me clean it up just a little bit here. This needs to be cleaner. There. So I do n plus 1 to the 5th minus 1 over n plus 1 times 2 to the n plus 1. Just change all of the n's to n plus 1. Once again, that's half the battle. If you get this, you got half credit. And then we just have to do some algebra. So flip the denominator and multiply. And you can see here that I wrote down that expansion that I had there, but I got a little tired, and so my handwriting got a little messy. It doesn't really matter though, because you know what's coming is when you do the limit, the only thing that really matters is this thing here. So, I mean, I could have written the whole thing down. I kind of did. If you zoom in, you can see 10 times n to the 3rd, 10 times n to the 4th. That's 5 times n, and then there's a little tiny 1 there. I know, you can't see it. It's pixels. They all bleed together. But anyway, on the bottom, yeah, this is after doing the algebra. Flip the denominator and multiply. So this ends up being down here. The n times 2 to the n ends up being up there. Okay, so far okay? Now it's just algebra. Sorry. It is hard algebra. So I'm going to multiply through, and I'm going to do FOIL, and I'm also going to combine those. So 3 things in 1 step. Hopefully you can handle it. So in the numerator, when I multiply by n, I get n to the 6th plus 5n to the 5th. It's there. Plus 10n to the 4th. Oh, it got so small you can't see it. But it's there. Anyway, so you got all that junk. And then when I multiply these two together, I actually wrote this out. N to the 6th plus n to the 5th. That's the outer terms. Minus n minus 1. All times 2 because those cancel and you're left with 2. Now I can do my limit. Limit is 1/2 because of the 2 there. That's less than 1. This converges. Is that all right? Okay, some of you are happy. Some of you are like, man, I got that backwards. It's okay. It's a learning experience for both of us. I know now not to put this. So here, let's just make a little note here. Test, here we go. Test must be easier than this. And this. Okay, there. Note to self. All right, now we need to move on though. We're doing roots, not root canals. We're doing roots, the root test. Where is my root test? Is it here? No, this isn't it. Hold on a minute. Gotta go find it. Where are the roots? Oh, they're in here. Yeah, I know, Superman. Here's where we are, the root test. Before we do the root test, let me explain where the root test comes from. You know this. So first of all, let me write this down. N goes from 0 to infinity of, how about, let's do 5 times 1/3 to the n power. Let's talk about that for a minute. And I'll find a volunteer to do this. Oh, in fact, no, we'll just leave it like that. Okay, hold on a sec. Where's my volunteer list? There we go. I know you're excited. Of course, half of you are missing. Random, you're missing. Oh, Gina's here though. Gina, what kind of series is this?
Geometric.
It is geometric. Yeah, just like the ratio test, this root test is going to be based on geometric series. So I need to know, does this converge? Owen, does this geometric series converge?
Yes.
How do you know?
The ratio is listed.
So 1/3 is between 1 and -1. Very nice. So that's how we know this converges. Now, in the ratio test, you literally compute a ratio of terms for your series, and you use that along with this rule. There are certain series that don't do well with ratios. For example, let's take a look at this particular series. So let's just imagine doing the ratio test with this. I don't have to imagine, I can actually try it. The ratio test would look something like this. I would do 5 over n plus 1 to the n plus 1 power all over 5 over n to the nth power. Now, I don't know about you, but I'm not sure what I'm going to do from here on out. I mean, this whole business of raising n to the nth power, and then what do we get? I don't want to have to even think about that. So I can do 5 to the n plus 1, but I certainly can't do n plus, well, I could. No, I couldn't algebraically. I'd have to wave my hand. I know what the answer is, by the way, but I just don't want to do it. So, because of that, whoops, not there, we have this thing called the ratio test. So the ratio test, so here, let me just, here is the root test. So ratio, you're doing this. The limit as n approaches infinity of a n plus 1 over a sub n. The root test, you do this. The limit as n approaches infinity of the nth root of a sub n. Now think about this for a minute. Why this would work is if you go back to your geometric series, do the nth root of this. Now, nth root of 5, let's ignore that for a minute. That's a number. But 1/3 to the nth power, you do the nth root of an nth power. So here, I'll do this over here. The nth root of 5 times the nth root of 1/3. And that's going to equal this, nth root of 5, 1/3 to the n, times 1/3. Now, I'll tell you what the nth root of 5 is. The nth root of 5, if you do the limit, is going to be 1. And if you don't believe me, ooh, it turned blue. Limit as n approaches infinity, 1/3. And the reason is, if you don't believe me, you can take 5 and do the 10th root of 5, and then the 15th root of 5, and then the 100th root of 5. You'll find that the numbers get closer and closer to 1. So there's that. Anyway, so that gets rid of this number, and you're just left with that common ratio again. So this is another way of taking a geometric series and pulling out the common ratio. So you can do that either with the ratio test, or in this case, the root test works just as well. It just looks a little bit more convoluted. However, this root test works with things like that are not as easy to do using the ratio test. So let me write down, I'll show you the root test. It's very similar. It's almost identical to the ratio test. So the root test, if you know how to do the ratio test, root test, basically the same. It's just how you get your number. You do the nth root of whatever it is. So here it is. Oh, don't write all this down. Let me highlight what you care about. What you care about is this, that if this limit is less than 1, then converge. If the limit is greater than 1, then diverge. And if the limit is equal to 1, then you don't know. So it's the same exact set of rules. With the ratio test, you had the same 3 rules. That if the ratio was less than 1, converge. Ratio was bigger than 1, diverge. And if it equals 1, don't know. The same 3 rules apply here. So all that's left is to take a look at a couple examples and then preview the homework, although we've been previewing the homework. So take a look at this nightmare. How would you test this series for convergence? Ratio test would be horrific, but the root test, I can do that really quickly. Watch this. Limit as n approaches infinity of the nth root of the absolute value of 2n plus 3 over 3n plus 2 to the nth power. Now the absolute value under there is just there to get rid of any negatives. So like if there was a -1 to the third power or to the nth power or something, it would get rid of the negatives so that you could do a root. You know that roots don't behave well with negative numbers. So this gets, that absolute value gets rid of that. So this is going to be the limit as n approaches infinity. Bear with me, I know some of you have already got the limit. And now, because you're doing the nth root of an nth power, you can cancel those. And now we get to the point where I'm just going to pick someone because you can all do this limit. Sarah, what is the limit as n approaches infinity of that thing there?
2/3?
It is just 2/3, yeah. We're used to these limits. They're fun. It's like happy days back when you were in Calculus 1 and things were easy. Okay, there it is. 2/3. Okay, next we have to remember 2/3, if that's the limit, does this original series converge or diverge? You know it does or doesn't. Lucas, what do you think? Does this converge or diverge? Yeah, because 2/3 is less than 1. This will be a convergent series. Or if you like to just put the C there, box it. Yeah, if you do just C or D, box it for me just so I can be like, where's the answer? Where's the answer? Oh, C. C is the answer. Okay. What's next? Hold on a sec. Okay, we got, let's see, we'll just skip that. There it is. So 2 more. Try these 2. And let me just tell you, to save us time, let's do it this way. This is going to be the ratio test, and this one will be the root test. So you got the ratio test and the root test. For reasons that may become obvious, if you try the root test with the top one, you'll find that it's difficult. And if you try the ratio test with the bottom one, you'll find it's difficult. So do the top one with the ratio test, do the bottom one with the root test. I want to make sure that we're setting these up correctly. So let's just get these set up, even if you haven't done the limit. So Haven, what would you put on the top of this ratio test here? Like this? Yeah, don't forget the parentheses, and I knew that you know that you need parentheses, but I want to make sure everyone understands that this is n plus 1 factorial, and this is e to the negative n plus 1. So it's in parentheses there to emphasize that it's not negative n plus 1, it's negative n plus 1. Excellent, so we got that. Pearson, what goes on the bottom of this thing?
E to the negative n times n factorial.
Excellent. All right, so there's the starting point there. If you didn't start there, then take a minute and see if you can finish it up from there.
Can you scroll down to the second?
Yes. Scroll. All right, let's see how we're doing. I'm going to go ahead and write this like this. Whoops, that wasn't right. I don't know why that line showed up there. Limit as n approaches infinity. This will be e to the negative n plus 1. Oh, sorry, I thought I had to.
You negate the negative.
Yes. Yeah, what does it mean for the, you mean negate the exponents?
The negatives in the exponent.
Yeah, so what does it mean for a negative exponent? Do you remember from algebra days? Yeah, it means it belongs on the wrong side, the other side of the line. So you can either do that, so negate by moving it to where it belongs, or you can just do the math and say, okay, this is going to be e to the negative n plus 1 minus negative n. That actually might be a little bit harder. So let me do what I think what you're referring to is this. No, you mean like, so this negative n plus 1 actually means it belongs down there. And then if you don't mind, I'm just going to do this. Because n plus 1 factorial over n factorial, if we were to write it out, everything would cancel except for the n plus 1. And then let's cancel these. Let's get a volunteer. You don't exist anymore. You are gone. Briar's here, though. You exist. Briar, how do I deal with that e to the n over e to the n plus 1? Very good. So this is going to be n plus 1 over e to the first, which is just e. All right, final step is the limit. Haven, you got picked a second time. What's the limit of that thing? So n's getting really big. So that numerator gets huge. It is infinity, yes, very nice. So yeah, it's in big number over e, which is infinity. Very nice. So this thing is greater than 1, which means this diverges. I should have picked someone, but that's all right. Diverge, diverge. Okay, good enough. I should have just put a big D. Big D, done. Questions about number 1? First one? I'll put a 1 there. All right, if you haven't done so already, make sure you start the root test, but let me make sure that we get started on the same footing. So we need to know what's going underneath that root there. So Marissa, what do I put inside that absolute value there?
Negative 1 to the n over the natural log of n to the n.
Very good. All right, good job. So if you haven't done it already, do that one. I'm just going to quickly get set up here. Man, all the sports stars are getting chosen. There they are. All right, so we'll start with this step. Alyssa, what happens to this -1 to the n when I apply that absolute value? Yeah, it's just, or just 1, because 1 to the n is just 1, right? So we'll just put a 1 there, or 1 to the n. 1 to the n is fine. So we start with this, and then to get from here, let's get rid of that radical. Let's see, running out of room. N approaches infinity. I'll zoom in a bit. It's about as far as I can go. Evan, what do you think? What happens when you apply the nth root to this thing?
Just 1 over natural log.
Yeah, just 1 over natural log. Very good. All right, now I need to do this limit, even though it doesn't look like a limit. Such a mess. But Sydney, you know what that limit is, don't you, when you do the limit as n approaches infinity of this? It is 0, yeah, because natural log of n just keeps getting bigger and bigger. So that ends up being 0. Very good, and so now we have to know what happens. Alyssa, my phone loves you as well. What happens if you get a 0 for a limit? Does this converge or diverge? It converges. And the reason is that the limit is less than 1, and so you converge. Yeah, so this root test is actually quite, it's very similar to the ratio test. So if you've mastered the ratio test, you've got the root test nearly done. All right, so the homework for Monday, remember it's due Monday. I know you want it to be due Tuesday, but if you do have major issues with it, come bug me on Monday morning, and we'll do it together. I could even push the time so that it's not due until after our class in quotes, because class is kind of optional, let's just say. I don't want to cancel it, but optional. Come if you want. So I'm going to be leaving, and I don't know that we need to talk anymore. We've talked about Monday. We don't need to talk about the homework, and I'm leaving on a jet plane. Don't know when I'll be back. Actually, I do know. That's just a song. All right, so yeah, stick around if you want to talk. Otherwise, I'm going to stop the stream.